Hello everyone, my name is Ikshans and in today's lecture we are going to discuss about Bode plot. We will discuss some easy steps to draw the Bode plot. So the only formula we need to draw the Bode plot is magnitude initial is equal to 20 log k plus slope at origin into log omega. So this is the only formula we need, guys. Let's start with the question. So convert this into time constant form. Time constant form. So in time constant form we have 2 into 1 plus s by 1 plus s by 2. In denominator we will take 5 as common and s as it is. Then here we have 1 plus s by 5. So guys, here this and this are the corner frequency, and the gain here is k. This k is the system's gain and k here is 2 by 5, which is we can say 4 by 10.4, where omega is equal to minimum non-zero corner frequency divided by 10. So here omega is 1 by 10 because 1 is here minimum non-zero corner frequency. So 1 by 10 we have 0.1 here. Now put the value of k omega into this formula. So putting value in equation 1, putting value in 1, we have m initial is equal to 20 log 0.4 minus 20 log 0.1. So this is minus 20, which is the slope of one pole. So as we discussed here, slope at the origin, we have to write the slope at the origin here. At origin we have one pole here, so at origin we have one pole, and one pole gives the slope of minus 20 dB per decade, and 1 0 gives the slope of plus 20 dB per decade. So we have one pole at the origin, so we are writing minus 20 dB here. This is the slope at the origin. Now solving this, magnitude initial is equal to (12.04 dB). So to draw the Bode plot, we need to draw the magnitude versus frequency part. This is omega, this is magnitude in dB. Okay, so m initial is magnitude at 0.1, omega is equal to 0.1. okay, so this is 12.04. we have the slope here minus 20 dB per decade, because we have one pole at the origin. So one pole at the origin, we have this thing from origin to so here we are putting omega is equal to 0.1, because guys omega is equal to 0.1 because when omega is equal to 0 we are this is just about at the origin. This is origin guys. If you put omega is equal to 0, then the log omega will be minus infinity. So that's why we are taking omega non-zero but least greater than 0. So omega is equal to 0.1 we are taking here. So we have one pole at the origin, so one pole at the origin, and this is giving the minus 20 dB per decade of slope. So at 1, this is the corner frequency guys. At 1 we have one 0 here, so for 0 this slope will be 0, because this is minus 20 dB. We will add minus 20 plus 20 dB because of 1 0. This was because of one pole. So at 1 0, at 1 we have 1 0 here, so the slope will be 0 dB per decade, because this is 0 dB. Okay, then at s is equal to 2 here we have another 0. So this 0 at s is omega is equal to 2. So this is at omega is equal to 2, we have another 0 here. This 0 will give 20 dB per decade of slope. So 0 plus 20, this is 20 dB per decade of slope. Then we have 5, this is the corner frequency, and at 5 we have one pole again. So this pole will make this again 0 dB, because this is 20 dB and minus 20 dB because of one pole, and this was because of 1 0. So this has been 0 dB per decade again, and the plot will continue to move as a 0 dB per decade for always up to omega is equal to infinity. Okay, so this is the Bode plot of this transfer function guys. So let's take another question and do it very directly. So this is our next question guys. This looks little bit lengthy, but we will do it directly and it's not gonna take that much time. So the thing which we have to do is m initial is equal to 20 log k is 0.1, and we have 1 0 at the origin, so plus 20 log omega is guys 0.1, 1 by 10 is omega, so this is 0.1. When we will solve this, we are going to get minus 20 here, minus 20 here, so minus 40 dB is the magnitude initial. So log 0.1 is minus 1, so minus 20, log 0.1 is minus 1, so minus 20 here also. This is omega, this is magnitude in dB. Okay, this is 0.1 here, then we have 1, then we have 10, 1, 10, then 20, then we have 50, then we have 100, then we have 200, then we have 500. So these are the corner frequency guys we have written here. The magnitude initial is guys minus 40 dB. So this, let's say this is minus 40 dB here. Then we have 1 0 at origin, so 1 0 means we have 20 dB per decade of slope. And after that at s is equal to 1 here we have one pole, so that will normalize the slope, and this will be 0 dB per decade. Then at s is equal to 10 we have two zeros, so s is equal to 10 we have two zeros, so the slope will be of 40 dB per decade. At omega is equal to 20 we have two poles, so that will also make it 0 dB per decade, so 0 is the slope of this line. Then at s is equal to 50 we have three zeros, so this will have 60 dB per decade slope. Then we have at s is equal to 100, so at omega is equal to 100 we have three poles, so 0 dB per decade again. At s is equal to 200 we have four zeros, so that will increase the slope to 80 dB per decade. After that we have four poles. At omega is equal to 500, so that will make the slope 0 dB per decade. So now up to infinity this will be 0 dB per decade. So this is the Bode plot of this question, guys. This was pretty simple. I hope you like the way I have solved the question.